Thanks for joining me. My name is David Nawalny. I'm a medical business development manager with Freescale Semiconductor. Today I was asked to tell you a little bit about Freescale's medical solutions that I can tell you are obviously meeting the requirements for next generation medical applications. Talk a little bit about the team we have, a little bit about some of the products and some of the value proposition that Freescale brings to the table. So first we'll look at Freescale's medical team. Freescale is led by Stephen Dean of our global sales and marketing organization. He's based in Tempe, Arizona, and manages from a sales and marketing side the entire United States and then also the globe. In each region, we have a segment focused on medical. Michael Rosen is the European segment manager. Jackson Liu is in the Asia Pacific region, and Furu Katsutoshi-san is based in Japan. We've also just recently created a medical metering and connectivity business unit, which is run by Director and GM Bruno Baylock, based in Toulouse, France. Also in Toulouse, France is Michael Viot, also a business development manager for the European region, specifically focused on medical. And then myself, based in the Americas. We also have a significant team of systems and applications folks, led by one Dr. Jose Fernandez, based out of Guadalajara. He's a global lead for all our systems and applications work in the medical space. We have Galitas, Ross Mitchell, and Patrice Bertrand. These gentlemen all reside in the European region as well and do a lot of specific systems, applications, and solutions engineering focused around the medical market space. Within Freescale, we do have some other business units that do have focus on medical. Sujata Naidig is based in our MAD organization with the really popular viot1 portfolio. Matt Short in our networking group, and then Wayne Chavez in our sensors analog team. So that's really the folks that you would come in contact with specifically focused on medical within Freescale. So the question is, in a lot of cases, why is Freescale focused on the medical market? I think one thing, and we're seeing a significant convergence of healthcare and technology. And why are we seeing that? I think a lot of it is to, one, improve the overall patient care, the level of patient care around the world, and then two, to lower the cost of healthcare. So these two key items are really what's causing the convergence of healthcare and technology. And if you really look at the cost of healthcare, what's costing the system the most amount of money, where I see, or we see Freescale the most amount of growth in the marketplace is in the care of chronic disease. And those chronic diseases I have listed here: obesity, diabetes, and cardiac disease. That accounts for a significant amount of the spend globally in healthcare costs. And with that said, that's really where Freescale is focusing a lot of its time, effort, and energy, is in devices that either cure, diagnose, or help treat these chronic diseases. You heard me mention one of the chronic diseases as being diabetes. Before we even get started, I'd like to talk a little bit about a success story. And this is really a Freescale success story showcasing some of the key features that we have in our overall product portfolio. The first is an viot1 solution, which actually fits in a handheld personal diabetes manager that you see there on the right hand of the screen. And then really the innovative piece of this equipment is the Omnipod. And this entire solution is branded and produced by a company called Insult Corporation, based out of Boston, Massachusetts. And this is essentially a personal diabetes manager and a insulin pump combination. And this device is completely wireless, completely tubeless, and really allows diabetics to not adjust their life for their overall chronic disease. They're basically almost able to go along without any sort of issues. They don't have any tubes, they don't have any wires. You really have a fairly free solution that really isn't going to affect your daily life. So I mean, it really is a great solution. And in this solution, I already mentioned that Freescale does have an viot1 product. But in addition to that, we also have a custom solution that's specifically based on an 8-bit processor does have some specific analog, and then also has a sub-gigahertz radio in for very low power communication. So this is a disposable type device, so you can really see in terms of the types of devices Freescale does. You have a wide variety. You have high-end multimedia processors, as well as things like a specific custom ASIC for these medical devices, and it's something that I think everyone should keep in mind as we're beginning to dive deeper into this market. And actually, with that said, I'd like to cut over to a video that we've actually put together specifically on the Insulet Omnipod.
Hi, I'm Steve Dean, Freescale Medical Segment Lead. Today I wanted to show you the Insulet Omnipod. This is an insulin delivery device. This is the control and monitor device right here. It's got a built-in blood glucose meter. You provide user input via the i.MX processor. Very cool device. This right here is a clear version of the product that you would buy off the shelf. I'll show you here in a second what's in here is a Freescale custom ASIC based on a Freescale 8-bit MCU, RF, and analog, all integrated into this device here, which is worn on the abdomen. Place it here, pull the tape, place it here, a subcutaneous needle comes out, and that's where you get the glucose reading and the insulin application right here in the patch. This would be the product that you would buy via the pharmacy. It includes the syringe where the insulin would be delivered into the device. It's worn for 3 days and disposed. So very nice application for Freescale. Freescale enablement. Again, it's Omnipod by Insulet. I wanted to call to your attention today Freescale's new medical applications guide. You can download that off of freescale.com/medical. Go there, take a look. Also blog, Medical by Design. Thank you.
Now I want to take a little bit of time to talk about Freescale's market solutions. Freescale has been and will continue to be a trusted provider of high-quality technical solutions that enable the development of breakthrough medical systems. There are really three key markets that Freescale is focused on. The first one is portable medical, consumer medical, both kind of interchangeable type terms. The other is diagnostics and therapy, and the third is imaging. I would say that in terms of initially, the Freescale product portfolio is very well positioned in both the home portable medical and also in the diagnostics and therapy space. And I listed a couple of requirements here. In the portable medical area, we have a pretty wide portfolio of highly integrated mixed signal microcontrollers operating at very low power with a multitude of connectivity options. And in the diagnostics and therapy, really the key pieces here end up being multimedia, very nice, high-quality graphics displays, the appropriate amount of connectivity, and then also just our sensor portfolio plays well in both those specific areas. In the imaging area, we do have a portfolio out of our networking group that really focuses on, we'll say, the high-end processing demands that would be needed in a imaging type device. So we do have multi-core type devices as well as DSP type devices for this specific application. A couple other key features: all of the products that we focus on and target towards medical customers do have up to a 15-year product longevity. So Freescale has a best-in-class product longevity program guaranteeing either 10 or 15 years depending on the specific product. So definitely something that ask your local salesperson about depending on the product you choose. But for all practical purposes, the products that we try to get in our customers' hands are the products that do have this assurance. And then another key piece, we'll talk a little bit more about wireless, but Freescale is a member of the Continua Health Alliance, which is an organization really looking to drive standardization among healthcare devices, both within the home and within the hospital environment. So Freescale sells into all U.S. FDA classes of devices. So I know around the world there are many different types of devices in the European region. The CE mark's kind of the gold standard for being able to sell and market your device. But what I wanted to make very apparent is looking at the FDA standards as they relate to CE and other global standards. Freescale has no problem selling into Class 1, Class 2, and Class 3 medical type devices. So the Class 3, we do have a standard operating procedure for those particular devices, but for all practical purposes, it's more to make the business unit GM aware of the risk that he or she is taking on. So looking at Freescale's value to the medical market, you heard me say trusted partner. We're also just a leader in healthcare technology, driving new products to market. And then with that said, we do have one of the widest product portfolios in the industry. So looking at our trusted partner capability, Freescale being derived from Motorola or being spun off from Motorola, we do have a over 40-year history of playing in the microcontroller space, microprocessor space. We've always been innovators there. And with that, with our customer base, we've always had long product lives, as much as even guaranteeing 10 or 15 years. Our quality and service is second to none, and with that applies across all different markets. Looking at specifically healthcare, we've done some specific things like creating the Medical Center of Excellence, which you heard me mention Dr. Jose Fernandez. He actually leads that Medical Center of Excellence based out of Guadalajara, Mexico. We're also members of the Continue Alliance, which I had touched on earlier, the consortium of companies really joining forces between healthcare and technology to set up these standards that will be abided by in terms of connectivity for both hospital care, clinical care, as well as home care. We also have a medical advisory board. Really, this is just a network of folks that we continually run our strategy by. This consists of folks that are in industry, as well as folks that are in the regulatory market. So we just really try to keep a pulse on an ever-changing or fast-changing healthcare market. And then lastly, having some strategic partnerships. The couple strategic partnerships that I do want to talk about. One is with a company called Cactus Semiconductor, which gives us the ability to really create complete solutions for our customers. When we talk about product portfolio, you can see that we have microcontrollers, microprocessors, sensors. We do have some analog in terms of power management. We have an extensive wireless portfolio, but one area that we are lacking is in the analog, specifically custom analog space. And this relationship with Cactus Semiconductor has helped us close that gap. And the folks at Cactus are very, very good at creating analog components and creating specific analog ASICs for both the diabetes and cardiac space. And then lastly, one other partnership I'd like to talk about is with a company called Manibo Technologies. And these folks have some specific software for decoding algorithms, or basically decoding an ECG. So they have specific algorithms for ECG analysis. And this is something that can be run on something as simple as a 32K flash 8-bit microcontroller. So definitely very lightweight and adds a lot of value to our product portfolio. So the next slide talks a little bit more in depth about our medical microcontroller roadmap. The real key products in our roadmap today are based on our ARM core Kinetis product family. So a year and a half ago, we came out with the Kinetis product family based on the Cortex M4. We have a wide variety of parts: K10, K20, K30, K40, K50, K60, K70. So basically varying degrees of capability and integration in those parts. Specifically the K50 product line with the integrated analog front end containing two 16-bit A to Ds, two operational amps, two transimpedance amplifiers, programmable gain amplifiers as well. So really a very full-featured part. So a lot of our products are, a lot of the products in the Kinetis product family do have a lot of applicability into the medical market. Another product family I don't want to ignore is our I.MX product family. And they really come into play, as you can see this slide is titled LCD and HMI Solutions Roadmap. So one of the key features of all medical devices is they all have some sort of output, whether it be something as simple as a small segment LCD like you see on the left-hand side of the screen, or something as complex as a patient monitor that wants a full HD display with touchscreen capabilities. So with that said, you can see here that Freescale really covers the gamut of those type of applications. With the SO8 portfolio, we have products like the SO8 LL, LH, LG. Moving into Kinetis, we have the Kinetis K30, K40, and K50 parts, all with segment LCD. And then moving into some of the higher end Kinetis parts, we also do have products that offer graphics controllers. And then for the very high end, those products that do need the most functional multimedia type or multimedia processors, we do have our i.MX product family, and the ones that have really been selling very well in the medical market have been the i.MX 233, the i.MX 28, and the i.MX 5X series of products. In addition to microcontrollers and microprocessors, Freescale also does have a very wide variety of sensor products. So we have both pressure sensors, proximity sensors, and inertial sensors. Business for things like pressure sensors fit very well into respiratory applications, blood pressure monitors, drug delivery for inhalers, or in any case where you may have a fluid level detection. Proximity sensors, anytime you have a touch screen or actually a no-touch type application, this is actually a little bit better using the gain of these devices. You don't necessarily need to touch, you can just get within a certain distance, which is again where the name proximity came from. But for all practical purposes, these could be similar to a touch sensing type device. We actually do have this technology integrated into some of our microcontrollers from Kinetis as well. And then lastly, inertial sensors. Really a great group of products that I think medical device manufacturers are just now figuring out what they can do with. So they look at these parts, and we're seeing them integrated into more and more device types, just in terms of activity sensors, any sort of sports diagnostics. So there's really a wide variety of applications for sensors in medical applications. And then lastly, we want to talk a little bit about wireless solutions. And really the most significant portfolio that Freescale has is Zigbee. And this Zigbee 802.15.4 product family can be used in things like a full mesh network, or can actually be used in things really as simple as point-to-point communication. And the 802.15.4 radios that we have available today are really fantastic for either of those options. It just really depends on one, do you need the network or do you not need the network? If you do not need the mesh network capability and you just need point-to-point, you can really use a much lighter weight stack, and also the potential to lower your power consumption. So our 802.15.4 products do give you a significant amount of flexibility. With that said, if you do want to standardize based on some of the continual guidelines, Freescale does support the Zigbee healthcare profile. So this was introduced in April 2010, so it's available for everyone to use now. And we've successfully completed the Zigbee Alliance healthcare profile interoperability testing. So should give you peace of mind that as you're designing your next generation medical devices on Zigbee, that you're not going to have any trouble passing that overall interoperability testing. So the products that we have in the market today, you can see listed at the bottom of the slide: the MC1320X, the 1321X, the 1322X, and the 1323X family. So really we have a wide variety of offerings in the marketplace for Zigbee. So looking a little bit more at the wireless ecosystem, it's interesting to mention that Zigbee is just one of the pieces of the puzzle and one of the players there. So you also see USB, and it's good for you to know that we also do offer free of charge or complimentary a personal healthcare device class USB stack, and that runs on all of our microcontrollers and microprocessors. And then also we do have experience in the sub-gig space. So we do have sub-gigahertz radio IP. We've just recently announced a sub-gigahertz radio product that is in the market today. And with that said, you'll see more sub-gigahertz products coming out from us in the future. So, really in terms of Freescale's product portfolio, having Zigbee as well as sub-gigahertz really has positioned us well in the market to capture a lot of the remote monitoring and telehealth, mHealth type applications. So lastly, it's very important for a semiconductor company to have a wide variety of development tools, software, and enablement. We're really trying to create solutions here. So it's one thing that Freescale, I think, has done a very good job of, and specifically targeting it towards medical. So having Freescale runtime software, complementary. So we acquired MQX, real-time operating system, a couple of years ago, and now we provide that to our customers free of charge. And with that integrated, we have the USB PHDC, as well as the Zigbee PHDC, which stands for Personal Healthcare Device Class. We also do offer a lot of value-added software, so standards-based software, human-machine interface software, and then have a bunch of market-specific reference designs, which if you go to www.freescale.com/medical, you'll find a lot of the content from those reference designs available on the web, and that comes in the way of schematics, application notes, block diagrams. All of that is up for a lot of our key applications. And then lastly, having a great development tool set with Code Warrior. We give you an Eclipse environment, code generation wizard, really good device initialization, and then software analysis, host platform support. So really provide a full-featured ecosystem of products for our medical device specific customers. And just to give you an example of the types of development systems we're actually sending home and providing with our customers, this is just a quick look at a board we call Med ECG. This actually ships from the factory with our Kinetis K50 product line. And you can actually get an ECG measurement as you see here. And actually stay tuned. I'll actually turn you over to take a look at a video of the Med ECG in action.
My name is Paul Medina, and I'm a Freescale product marketer for microcontrollers. Today I'll show you a demo that is based on our latest Kinetis K50 ARM Cortex-M4 microcontroller. This microcontroller has an integrated measurement engine, and it has integrated operational and transimpedance amplifiers. So let's take a look at the Kinetis K50 evaluation board, which is the TWR K53 N512, and basically I have connected a pulse oximeter analog front end together with a pulse oximeter sensors. We have, besides that, other analog front ends like the EKG, which you can find a lot of information in the Freescale webpage. The development board name is Med EKG. We have also the spirometer analog front end, which is basically using a Freescale pressure sensor, the 7050 family. And finally, we have the blood pressure monitor analog front end, which is also using the 7050 pressure sensor from Freescale. So let's take a look at the demonstration. I'm going to connect my finger to the pulse oximetry sensor, and basically you start seeing how the Kinetis K50 starts instrumenting the signal, converting from current to voltage and amplifying the signal so you can get a heart rate calculation, and of course the oxygen saturation reading, which is really nice, around 99%. So basically that's all I have right now, and if you want more details about this, you can go to our Freescale-medical webpage or Freescale-K50 webpage. Thanks a lot.
After reviewing Freescale solutions, let's go deeper into design your specific medical design using Kinetis integrated analog front end. The Kinetis K50 microcontrollers contains a Cortex-M4 core. It also has an integrated measurement engine used to read industrial sensors like a temperature or liquid sensor or a portable medical devices. There's a wide range of applications that the K50 can target. The family also offers different monitoring options. The most obvious is the internet connection, but it also offers an LCD controller for local monitoring or an external boost interface connected to a graphic LCD. It also offers several serial interfaces like I2C, SPI, and UARTs. The K50 is fully compatible with existing Kinetis devices, so there's a freedom to start with a K40 and expand to a K50 device when analog signal processes is needed. The K50 itself offers 40 different devices to choose from. There's also a freedom to choose from an ADD like our Codewire or IR, Kyle, and Green Hills. The devices themselves are very easy to use. Initializing the op-amp or 3amps takes 4 lines of code. Add this easy in peripheral to use to have module development platforms like the tower. The K50 is part of the Kinetis portfolio, which I said adds up to more than 200 devices. The family key differentiator is the integrated measurement engine, but it also features USB connectivity on all of the devices as Ethernet and segment LCD controllers. The K50 family shares a lot of peripherals with the rest of the Kinetis portfolio, like the ones on the right of the slide. Same memory modules, SRAM and flash, so it's easy for a customer to start in any of the rest of the Kinetis family and then use the K50 as they have higher needs for analog signal processing. The measurement engine has up to two high-speed 16-bit ADCs, up to 2 programmable gain amplifiers with a 64 gain, up to 3 high-speed comparators, up to 2 TACs, analog voltage reference, and up to 2 operational amplifiers. It also has up to 2 transimpedance amplifier and a programmable delay block to generate delays to trigger the ADC conversions or DAC waveform generator. The measurement engine has internal connections like the output of the DAC0 can be an internal channel for the ADD, a voltage reference for the comparator, or inputs for the 2 internal operational amplifiers. The DAC0 also is connected with the op-amp 1. It's also a voltage reference for the comparator 2, and it has its own single-ended input to the ADD 1. The output of the op-amp can be read via an internal channel for the ADC0. It can also be an input for the comparator 1, an input of the same op-amp, or an input for the op-amp number 1. Op-amp number 1 also has its own channels in the ADC0. It can also be connected with the op-amp 0 or with the op-amp 1, and it also has an internal connection with the comparator 2. We also have a voltage reference module that can be used to like the reference for the DAC and for the reference for the CMPs. And it also can be a single-ended input for the ADC1. We also have a differential input connected to the transimpedance amplifier number 1. The PDV can be used to generate delays for the DAC in order to generate waveforms. And it also can hardware trigger ADD0 and ADD1 conversions. And there is a feedback between the PDV and the ADD, so you can generate a back-to-back operation where the ADC is able to tell to the PDV that it finished its conversions and it needs to start another conversion. So there is no software needed in this, and you can reduce the CPU usage a lot. And finally, the CMP0 can trigger the PDV to start counting, and it also has an internal connection with the op-amp. The main features of our 16-bit ADD is that it has differential or single-ended inputs. It has a programmable gain amplifier up to 64 gain. It also has a SAR up to 16-bit resolution. It can have single or continuous conversions. You can configure the sample time and the conversion speed needed for your application. It also has hardware average, automatic compare, operates in low power modes, and a selectable hardware conversion trigger. And the module also has a self-calibration mode. Our digital to analog converter has a 12-bit digital input. It has a 504 DMA support, on-chip programmable reference output for a generator for voltage reference. It also has selectable reference voltage, allows corrective trimming to improve voltage accuracy. The DAC can be used to supply an accurate and fixed voltage output, configurable trigger sources, and it has a 16-word data buffer where you can move around to generate different waveforms if you need it. It also has a configurable watermark. The programmable delay block provides controllable delays to the programmable intervals. It also has a sample trigger input to one or more ADC, and it's a hardware trigger to the DAC. The PDV can start its counts by the CMP outputs, a conversion complete triggered by the ADE or by software. The PDV allows timing control over ADC conversions and DAC updates. It has also delay register to schedule timer intervals, and it has a trigger output to advance the DAC pointer. It's also a timer with a counting register and a module register. An electrogram is a graph that records the electrical activity of the heart over the time, allowing healthcare providers to diagnose a wide range of heart conditions. Portable ECGs is the most used test to measure the functionality and pathology of the heart. The functionality of an electrocardiograph is based in this electrical activity of the heart cells, the depolarization that contracts the heart and creates heartbeats. The signal obtained is called a QRS complex. The heart is composed of 4 chambers, 2 atriums and 2 ventricles. The right atrium receives the blood returning from the heart from the whole body. That blood passes through the right ventricle and it's pumped to the lungs where it's oxygenated and goes back to the heart through the left atrium. Then the blood passes through the left ventricle and is pumped again to distribute it to the entire body through the arteries. The electrical impulse generated by the heart, it's composed by a series of events. Those events is that the atrium begins to depolarize, then the atrium finishes to depolarize, the ventricle begins to depolarize, and the apex, the ventricle depolarizes, the ventricle begins to repolarize, and the apex and the ventricle repolarize. These 6 steps generate the QRS complex. This electrical sign is tied to the heartbeat of your heart. Freescale offers a medical EKG analog front end that is composed by external instrumentation amplifier, a bandpass, an op-amp, a notch filter connected to the DSC. Or it also has another way to use the measurement engine inside the Freescale Kinetis K50 to build an instrumentation amplifier using the 2 internal transimpedance amplifiers and an op-amp, then generate a bandpass, and with the missing internal op-amp you can generate a notch filter. This is the schematics used in the medical analog front end, where the 2 internal 3 amps were used to convert from current to voltage. Then we have the internal op-amp to generate the bandpass filter. We talk about that the DSP has a Cortex M4 micro ARM core inside. This this M4 has the capability to generate DSP instructions. DSP and filters on an ECG are tied together. ECG are small signals that are very susceptible to noise, and there are different noise sources from an ECG implementation, like muscle contractions, respiration, electromagnetic interface, and power lines. The need to implement different filters to have a good quality of the signal so you can have a great QRS complex. The band reject or notch filter rejects the 60 Hz or 50 Hz, eliminates power line noise, and the QRS complex is now clean and ready to be processed, and the low ordered and fast to execute. The ECG also needs a bandpass filter between 0.5 Hz to 150 Hz. It lowers the limit from removing the muscle and respiration noise. It has higher limit to avoid high frequency signals, and the heart rate frequencies is within the range of that filter. High order filters around high 500 coefficients, and it has better signal quality. So implemented these two type of filters, you can pass from the signal to your right to your left to the signal to the right. And all of this was inside the microcontroller without the use of external components. The software architecture that we use to generate our ECG is we have the USB PHDC support software that evaluates a request. If the request is to start the measurement, we ask if we are currently measured. If we are not, then we initialize the ADC and our current state will be measuring. Then we start the timer. After that, we send our confirmation. If our request was to stop the measurement, we stop the timer and we go to idle. If our current state is to start measurement, we measure the new samples from the ADD. If our new samples are, then our new samples state will be false. We read the ADD, we read the ECG signal value, and we start a timer. Then we go to a control algorithm, and this control algorithm would tell us if our time pulses is above 2.5 seconds. If a peak was detected, this means that the heartbeat happens. If it's a valid pulse, we calculate and store the new real-time heart rate in a heart rate array, and then we send all this data to a buffer for the ECG. If this ECG buffer is full, then we send this data through the USB with our serial communication new data ready. We have a medical EKG demo. This demo needs a Freescale Tower serial kit. It's the Tower K53 kit that contains a Tower serial card, the Tower K53 board, and the elevators. You also need to order the MED EKG analog front end. Once you have the hardware, go to freescale.com and at the keyword search, look for the application note EAN4323. Once you have your search going, the following results will appear. We have an application note that contains all the data that I show you today, and you can also download the software.
Hi, I'm Dr. Jose Fernandez from Freescale Medical Product Marketing Team, and today we're at the Mexican Institute for Aesthetic and Anti-Aging Medicine with Head Chief Director Dr. Abelardo Guzman. He is a colonial plastic surgeon and craniofacial reconstructive surgeon as well. Hi, Doctor. How are you today?
It's a very pleasure to see you again, Pepe.
So he has been really kind to let us show this video at the Institute operating room, and we are with one of his patients. And so, doctor, when you have a patient, what are the most common parameters that you take from your patient?
Well, the most common are the heart rate, the respiration rate, the oximetry or saturation rate. Practically that are the most common parameters. We need to supervise the patients.
So what do you think of a really portable, affordable, power-saving solution that you can attach to your patient and monitor remotely that I want to show you today?
Okay, well, I think that will be extraordinary. Extraordinary, because I'm sure with that machine we can examine and supervise anytime, any place, the patient.
Great.
That is, in a moment, is the dream of all surgeons.
Great. So what I have here is a K53 tower board. This has MCU from our family, the Cineris family. And what we have here is that a medical connector, and you can virtually plug in some of the analog front ends that I'm going to show you that we call the medical boards. Right now we have the patient with a MediKG, that is an electrocardiograph. We also have other boards like a blood pressure monitor. As you say, some of the important parameters is to have the respiratory and pulmonary function. So what we have here is a spirometer. And to measure the oxygen saturation of the patient, we have the pulse oximeter. All of these boards can also be plugged into other different Freescale's tower MCUs, like the Flexis MM, and you don't have to do any hardware or software redesign.
The K50 MCU family is beam, peripheral, and software compatible with other Cineris microcontrollers and provides designers with an analog measurement engine consisting of integrated operational and transimpedance amplifiers and high-resolution ADC and DAC modules. The family also features IEEE 1588 Ethernet and hardware encryption, full-speed USB 2.0 on the go, with device charger detect capability and a flexible low-power segment LCD controller with support for up to 320 segments. Devices start from 128 kilobytes of flash in 64 UFM packages, extending up to 512 kilobytes in a 144 MAP VGA package.
So doctor, let me show you how easy this is to connect to your patient. We have attached 3 electrodes, disposable electrodes, and medical grade cables is for the MediKG board that attach to the Tower K53 board. And what we have here is the readings of a full 1-lead ECG. So if you want to change and have another, you just have to disconnect the tower board, plug in another one, and you can change easily to a pulse oximeter by just changing in the graphic user interface to start taking the measurement. So the Cineris K50 device provides an integrated solution suitable for use in portable medical applications such as pulse oximeter, blood pressure monitor, and monitoring ECG. Its embedded measurement engine reduces external component count and PCB size. It is low power features that make batteries last much more longer. I hope you have enjoyed this presentation, and I would like to invite you to visit the Institute for the Mexican Institute for Aesthetic and Anti-Aging Medicine at www.imae.net, and also the Freescale Medical webpage at www.freescale.com/medical.
Thanks for joining me again. My name is David Nwalny, Medical Business Development Manager with Freescale Semiconductor. In this session, we're going to talk a little bit about lowering the cost of healthcare through telehealth. And through that, I'm going to be introducing one of Freescale's more innovative technologies, the Home Health Hub. This is actually a reference design based on the Atom X28 platform that integrates a lot of wireless technologies specifically for the telehealth, telemedicine market. So there's a significant opportunity. U.S. healthcare does have a significant cost problem. healthcare isn't just U.S. based. The data I have here is U.S. based, but this is a global problem. And with that, I think there's a lot of medical device manufacturers out there trying to solve this problem. But just to give you some stats, healthcare as a share of GDP in the U.S. is currently above 17.6%, projected to be at 25% in 2025, and as high as 37% of GDP by 2050. Per capita spending is greater than $8,000. In addition to that, there's a significant shortage of physicians. This is being driven by a significant aging population. 2009 data shows that about 13% of the population is greater than 65. That's 1 in 8 Americans. Looking at 2030, that's projected to move up to 19. And again, this is something that you don't just see in the U.S., it's something you do see globally. And one of the biggest costs to our healthcare system is chronic disease. Costs $1.87 trillion. 3 out of every 4 healthcare dollars spent in the U.S. are on the care of chronic disease. What's the solution? The solution is really to enable individuals to take an active role in their healthcare, allowing them to proactively prevent costly chronic health problems later in life. And even with that, those with chronic health problems today, one of the solutions is having them be more proactive about managing their condition. An example would be someone with diabetes or someone with a cardiac disease. Instead of waiting until that they're actually to the point where they need to go to the emergency room and have an emergency room visit, monitoring their health on a regular basis, and getting feedback actually from a medical professional to make sure that they don't have the costly ER visits. So how can you do this? Both preventive medicine as well as chronic care. That's through telehealth, telemedicine solutions. And you can see from the slide that I have here, essentially the wellness and fitness market appeals to the younger generations, and that's more of a preventive healthcare model. And then home healthcare or remote patient monitoring applies to the aging population, those already with chronic disease. And this isn't something, again, U.S.-centric. This is something that really has global impact and has the ability to lower healthcare costs. So what exactly do we mean when we talk about medical health, wellness, and fitness applications? I've listed quite a few of them on this slide here. ECG, heart rate, a CPAP machine, things like connected pill bottles, activity monitors, diabetes care, weight scale, blood pressure, multi-parameter monitors, checking lung health through a spirometer, pulse oximetry type devices. So all of these devices could be used individually or collectively to manage either a chronic condition or, in many cases, just manage your overall health and wellness. So all of those devices are available today. The real key is how do you get that data to a medical professional quickly and easily? And that's really where Freescale came out with the Home Health Hub reference platform. It's essentially a reference design that speeds and eases development for a lot of these emerging telehealth applications. Uses seamless connectivity and data aggregation to promote remote access and overall improved healthcare management. So really the keys to any reference design are faster development. So in this case, you'll see as we go to the next slide, we've created a complete solution for our customers. We've created a complete design that we offer through a partner of ours with all of the software on top of it. Gives you secure connectivity of 3 different or 4 different wireless protocols, and then also just gives you an overall higher return on your investment in that, our end customers are not going to need to make that overall R&D investment to design this product. This is a product that they can actually take from us, and it's not as turnkey as just slapping a label on the outside, but it will definitely significantly speed their development time and time to market, being that we have the processors picked out, we have the solution really optimized for a remote monitoring or medical gateway. So what does this look like? On the slide in front of you, you'll see the Home Health Hub platform. You see the gateway platform, which communicates via Wi-Fi to something like a tablet. But the real key here is the multiple wireless connectivity type options that you have. Essentially, the medical device community has yet to standardize on a wireless technology. which in many cases makes choosing a gateway difficult. In this case, we took all of the wireless technologies currently being used in healthcare. That's Zigbee, Bluetooth, Bluetooth Low Energy, and even sub-gigahertz type solutions. So all of these solutions can connect to Freescale's Home Health Hub reference design. And as you can see here, we even have wired protocols such as USB and Ethernet. All of this data can then be collected and sent to a physician, to a social networking site, to a monitoring center, or to a loved one, all through cloud computing. So all of this can be stored, as we collectively say, in the cloud. So looking at the solution, what we are providing is a product that contains our i.MX28 multimedia part, specifically for the main applications processor in this design. And then with that, we also have a sub-gigahertz solution in the MC12311 product. So that's a new product from Freescale featuring sub-gigahertz radio technology. And then we also have our Zigbee product line specifically in these end products. So you can essentially see this is a very full-featured solution and really solves a problem that is currently out there in the telehealth, telemonitoring market, with essentially people wanting to gather this wireless data but not having one complete solution to do it. Freescale now does offer that complete solution through our partner, Digi International, and through them you can actually get a development system and begin developing your own medical gateway or telemedicine gateway or home health hub. So really Freescale becomes a significant enabler. So just quickly in summary, healthcare costs are higher than ever before, and one of the key ways that myself, as well as I think a lot of other folks specifically focused in the telehealth, telemedicine area, believe that remote patient monitoring and wireless healthcare is a great way to help lower those healthcare costs. And then with that, Freescale offers a comprehensive solution to allow a lot of these innovative companies that don't want to invest in the R&D and get a product to market quick. It really allows them to focus on what they know best, which is the medical technology, and they can just take a essentially off-the-shelf solution, which is what Freescale is offering, and essentially with a short amount of development work, bring a product to market. If you need any more information, you can go to www.freescale.com/home health hub. You'll learn all about the home health hub, block diagrams. There'll be some videos there as well. So thanks again for the opportunity to share with you a lot of the exciting things that Freescale is doing in the area of medical technology. And with this, I'll leave you with a video from the Freescale Technology Forum of the Home Health Hub in action. Thank you.
Hi, I'm Steve Dean, Freescale Medical Segment Lead. I'm coming to you from a simulated bedroom environment where today we have Freescale's Home Health Hub reference design on display. Home Health Hub, in other terms, it's a data aggregator for your patient records. In this case, it's through an i.MX 283 based design right here. That communicates Wi-Fi and all these various sensors, which I'll get to in a second, to this tablet design, which is i.MX 53 based. Here you can see I can step through my various tests that I might want to take. In this case, blood glucose. Very, very slick user interface provided by UI-Centric. One of the sensors that we have integrated into this system today is a life source blood pressure cuff using Freescale's MC13224V platform in package Zigbee solution. We have the same solution integrated into the life source weight scale. Down below, this glucose meter is connected to the hub via Bluetooth, as is this digital thermometer connected to the Health Hub via Bluetooth. So we have all these sensors fully integrated and working here. really the compelling thing about this solution is not only does it help carve healthcare costs out of developed countries such as the United States, but it also helps provide access. The same technology can provide access to countries that need healthcare access. Emerging countries such as India, China, and remote regions of the world actually can solve the access problem with the same technology. So that's the compelling story behind this. So the data aggregator or home health hub will take your data, pipe it up to the medical cloud into a service such as Microsoft Health Vault, where there a caregiver can download your information, make decisions based on trends as opposed to chronic conditions. You as a patient can download, take a look at your own data, see how you're doing over time, look at trends, make better decisions in the way that you choose to live your life. So that's one way that the data is used and will likely be used in the long-term future. One of the things that I wanted to show you today also, we do have a brand new medical applications guide. You can go to freescale.com/medical and download that. Also on that site, you can blog with us. Please share your thoughts and ideas. We'd love to communicate with you there. And that's what I'd like to show today. Thank you very much.
Hopefully you found that entertaining. Thanks again for the opportunity to come talk to you guys a little bit about what Freescale is doing in the medical space, how we're differentiating ourselves, what products we have, what features we have, and really why we're a more compelling solution than some of the other solutions in the marketplace. So I went through some of the people that are part of this team. Don't hesitate to reach out and contact us at any time. And if you do just need some information such as data sheets, schematics, block diagrams, we do have that all available at www.freescale.com/medical. Thanks again.